All right, so this new section here is all about something called type narrowing, which probably sounds a little bit more intense than it actually is. Nothing we're going to cover here is difficult to wrap your head around. It's all hopefully straightforward, but it's also a very important part of working with TypeScript. So type narrowing refers to a really common situation where we have some less precise type, let's say a union type, and we need to then narrow that down to a more precise type. So we could write a function like, this function called triple that accepts some value. And that value can be a number or a string. For whatever reason, we want it to work in both situations. And if you pass in a number like 3, I want it to triple that value and give us 9. But if you pass in a string like hi, I want it to repeat that string 3 times and give us hi, hi, hi. So we're tripling this string. Silly example, but that's okay. We have different behavior based upon the type of value. So how would we go about implementing this? We can't just do something like, number value times 3, like return value times 3, because TypeScript is smart and it knows, well, this could be a string, it could be a number, and it won't let me do this arithmetic operation since the left-hand side has to be any number, big int, or an enum. So a string is not allowed. So that's not going to work. Likewise, I can't just do my repeat, value.repeat 3 times, and if you're not familiar with the repeat method, it's just a string method, repeat 3. It just repeats that string for us and makes a new string. So I can't do that because, of course, number doesn't have that method, right? There's no repeat method on number. It only exists on string. So we need to get more precise. We need to narrow the type down inside this function. At one point, we need to check, all right, are we working with a number? If we are, we're going to do this. If we're working with a string, we're going to do this other thing. And the easiest way of doing this is to use something called a Typeof Guard. Now, this is a fancy term for something that you probably would just try anyway. You don't need to know about something called a Typeof Guard. Most of you would probably just try using typeof. So typeof is great when we know we're working with primitives like strings, numbers, booleans. Just as a quick recap, typeof is going to return to us the type of, if I give it a string, it returns a string of the word string. If I do type of some number, it's a string that says number. But where it starts to fail and it doesn't fail, but where it leaves us short or doesn't do as much as we might want is if I have, an array, right? It's going to just say that's an object. That's the type of object. It doesn't say that's an array. So we have other options that we'll get into in this section for narrowing the type to figure out if something is of a type of some particular class, if something is an array, if something implements an interface. But right now we're dealing with primitives, strings and numbers, so we can simply use typeof. So this concept of a guard is basically just using typeof in a conditional. It's a fancy phrase that refers to doing this right here. If type of value, and then do we want to check if it's a number first or a string? Let's see if it's equal to string. In here, if we look at value now, first of all, we as humans hopefully recognize that if we make it to this point, value is going to be a string because type of returns string. But TypeScript is analyzing my code, and it knows right in here that it is a string. That's the only choice. So it can look at the context. It looks at this type of and the conditional. And down here, it can't say that. It can't know with certainty. It says value could be a string or a number. It's not narrowed down here. But right here, it has been narrowed. Okay, so now we can do something like return value.repeat 3 times. And we don't get an error because TypeScript knows this is a string. Okay, so then we return that. And because we've now returned, this is the extra fancy part, down here, TypeScript knows the only way we make it here is if value is a number. So it's not only analyzing the conditionals, it's analyzing the return statements. And it knows the function is done if we get here. There is no way, if value is a string, there's no way we make it to this. So now I could simply return value times 3 if that's what I want, and we'll be returning a number. So triple, I'm not annotating right now, but TypeScript's inferred annotation for the return type is string or number, which is fine. Okay, so that's an example of a type of guard. We use a type of operator with some value that has a less precise type, and then we try and narrow it down. We use a conditional, and then we can do something in there, and TypeScript won't yell at us. TypeScript knows that we've narrowed the type successfully, and here value is definitely a string, whereas up here, value is either string or number. And that's a simple example, right? We could have different types. We could have a Boolean, for example. But in general, type of is going to work great when we're working with primitive types. That is one type guard.